Hello everyone, I am Mayank from Team Solid Body and I would like to discuss our solution regarding the dual arm robotic design. So our information flows in 6 contents. Firstly, starting off with introduction, moving on to part explanation, we would see each and every part along with its dimensions. Then we would go to the assembly where we would see a detailed video regarding our assembly constraints as well as the joints we have applied. Then moving on to novel features, we will slightly touch about the features that we applied and are not very easily seen in robotic arms. Finally, we would see a render as well as a conclusion. So firstly, talking about the introduction, I would like to firstly discuss about the thought process, why we got this specific design. So when we got a problem statement, we started to immediately research on internet about the existing solutions available to get an idea. So when we saw it, we saw a major gap that either the designs are too complex to understand or it does not simply gets the result done and or the purpose it does not fulfill the purpose. So to work on this, we worked on a robotic arm. We designed its joints individually and that are not too cluttered on a specific point, making it easier to assemble as well as disassemble. Now talking about the part, we will firstly talk about the fixed base, which is the basically the body of the robotic arm, which in which each and every support is attached, and basically it is an anchor. So we can see that it is a 450 mm long base with the breadth of 225 mm. And next we can see the bicep arm, which is basically the shoulder or the bicep in the human arm. It is helped to provide two joints, for two revolute joint, firstly which will provide rotation about its own axis, and secondly it can also replicate a perpendicular plane, like it can also move perpendicularly to the joint uh, along its own axis. Now moving to the forearm, which has a single revolute joint, which will basically mimic an up and down motion to to for the end effector to pick it. Now it is a claw holder. A claw holder is basically a rotation. It is helped to provide a rotation to the end effector in on its own axis, so as to improve its degree of freedom. We will see this in detailed in the assembly part, and this is simply a hand gripper which uses a rack and pinion mechanism. So now we will see a detailed assembly explanation. In this design, now we will see what all revolute joints we have applied. So firstly we will see this revolute joint in which the arm can basically rotate on its own axis, or the bicep, and this allows us to move perpendicularly or rotate perpendicularly to the joint. Now we will see the forearm, which has a single revolute joint as we already discussed, which also provides a degree of freedom. This is a claw holder which provides a degree of rotation along its own axis, and we have a gripper also attached, as we can see. Now I would like to talk about some of the novel features of our design. So as our whole purpose was to create it less complex, the first novel feature makes it to be its decreased complexity. As we have decreased the complexity, we can say that it is easier to iterate for changing the parts and making it more configurationably easy. And third would be a compact design due to the arm being more or less around 50 centimeters or 500 mm. And fourth would be using a worm gear reduction for driving the revolute joints, so as to improve overall torque and reduce the power consumption by the motor. Now I would like to show a small render of the assembly, which will be a render video. So this is how our model would look closer to a reality. Now finally concluding our design, our main purpose was to demonstrate a human-inspired robotic arm and to reduce and also reduce this complexity to make it easier to understand as well as easier to assemble and disassemble. So we carefully selected our joints and actuations to achieve a controlled movement. So this thoughtful design helps to effectively deliver a robotic arm like a human arm assembly. So I would now like to thank everyone for listening to us on behalf of my team. Thank you.